First, I don't want to skip that we have to thank these great speakers of today. You cannot imagine, they are really the top of Europe nowadays, and we are really privileged to have them today with us in our lecture series. I would like to remember which are the objectives of the lecture series. They are an important education inside the project of EPIC, which is an Horizon 2020 Electric Propulsion SRC, funded by the European Union. And education, I can tell you, it's a very important thing for the Commission and the European Union. Its objective is clear: is to provide these lectures to the science and engineering university students, bachelor, master, and PhD level, with the content of electric propulsion from basic technologies to latest developments in electric propulsion, which is our aim to promote electric propulsion talents and interest on you, university students, to prepare the new generation of electric propulsion professionals. Of course, I did not get anything, but I would like to highlight some important things that I get, maybe half of them. But of course, today we cover different types of thrusters, depending on the missions, depending on the physics. We cover the figures of merit, specific impulse, efficient, thruster-power ratio, lifetime, very important, exhaust velocity. Jose covered the ESA missions, technology one, science. We see JORGE, Smart One, BEPI, LISA, and also the electric propulsion preparation for telecom, Neosat and Electra. We learn about electric propulsion in telecommunication market, in GEO. We understand how important it is to have high ISP, although we have low thrust, and but we have to pay longer times to reach GEO from 3 to 6 months for full electric. We understand which are the functions of electric propulsion in a GEO telecom, station keeping, and orbit racing, two different things. And based on that, you can choose different configurations: full chemical, hybrid, chemical plus electric propulsion for station keeping, or full electric. Full electric has some drawbacks, but it's really a goal to save mass and cost. We also learn about the plasma physics, their characterization, the plasma with probes and detectors. We learn which are the maneuvers possible with electric propulsion: station keeping, north, south, east, west, orbit racing, from GTO to GEO, the orbiting maneuverings, drag compensation, such in JORGE, interplanetary missions that maybe could not be possible without electric propulsion, precise throttlability for some missions, or even formation flying. We learn about PPU functions and its parts. It's the core, the control part, the thruster supplies, the neutralizer supplies, and the fluid control unit supplies. We learn which are the key factors of the PPUs, the electronics, which is high voltage, which is the cost, and all of this about PPU was done by a Spanish. The lecture was given by a Spanish company that you have it really close in Tres Cantos, a future possibility for employ. We learn a lot about grid ion engines with this basic principia, its processes from ionization, different types, acceleration with grids, and neutralization with the cathodes. Professor Aedo extensively explained us the basic or complex principia of Hall effect thrusters. We learned that everything is mixed at the same time, and he went to its historic developments. We finally learned how the thrust is produced in the Hall effect thrusters, and the problems of erosion and lifetime. And we have an interesting comparison between the Hall effect thruster and grid ion engines, and their merits, the drawbacks, and their both possibilities and optimization for different missions. We see the results of simulations, trying to simulate the physics of the Hall effect thrusters. Our expertise from Monera, Denise, gave us a presentation on radio frequency plasma sources for electric propulsion. We learned about how the radio frequency thrusters works, the REIG, the ERC, and the helicon plasma thrusters. They don't need neutralizers, so they are simpler design and lower cost expected, but still the performance are not yet confirmed. And we learn in detail the ERC resonance thruster. Very interesting, the presentation about thruster types by topology of electric field and magnetic field. It gives a lot of insight about what is going on and how is produced the thrust in the different types of thrusters. And finally, we have a extremely complete presentation about magnetic nozzles, their types, and how they work. In conclusion, I think I can say that the EPIC lecture series has proven a great mean of electric propulsion education and dissemination, covering from basic missions, from subsystems to new concept. Even we incorporate in our talks business aspects. You see that cost is always there. We have a great audience today from universities, students of Madrid and researchers. At the beginning of the day, it was half of the audience. It was 20 minutes ago, full packed, so great. It is key to collaboration with local universities, in this case, University Carlos III of Madrid. Thank you very much, Eduardo, because it was a great lecture series. It is crucial also the advantage of organizing the lecture series in concurrence with the EPIC workshop. You students don't know, but we have been working here 3 days, full days, with top and latest developments in electric propulsion, and that's why we had the luck to have with us really top experts in Europe. And last but not least, the dissemination impact of having the lecture series and presentations on the web and video recorded will be really a boosting factor for the dissemination and education of electric propulsion, because if you want, during the weekend, you can be there, and instead of watching TV, click on and watch the lecture series. Our next milestone is going to be in 1 year, in October 2018, in London. Maybe some of you will not be able to be, but the weekend after, you will be able to be relaxed at home and click and watch the lecture series. Thank you very much. All the material will be on the web. Maybe not tomorrow morning, but I will try during the next week. Follow us in Twitter, and thank you very much. Okay, we can declare the lecture series over. Thank you.